Hello everyone, this is How I Love Geometry. I'm Mr. Cao. Today's problem is 2010 Aime2 problem number 9. I don't copy the problem, but I draw the graphs of this problem because geometry problem, if you see the graph, most of them will be very clear. So I just introduce A, B, C, D, E, F is a regular hexagon, and G, H, I, J, K, L is the middle point of A, B, B, C, so on. And we connect A, H, B, I, C, J, and so on. Then we got inside, we got a new small regular hexagon, M, N, O, P, Q, R. The problem asks us the ratio of the area regular small hexagon M, N, O, P, Q, R over A, B, C, D, E, F. So it can be expressed like M over N, the ratio can express like M and N, of course, no common factors. Then find M plus N. That's the problem. Okay. We're familiar with the regular hexagon. So here is the middle point. And we want to find the ratio of the area. So two ways. One, to get the area of a small one and the area of the larger one. Or you can use, because all of the regular hexagon is similar. So we can cut the ratio of the sides, then squared. It's also the ratio of the area. So let us, it will not lose generally. So we can say AB, let us suppose AB equals 2, and then AG will 1 and 1 and 1, right? And easily to get the area of for the ABCDEF, because this side is 2, right? Okay, that's not the point. How to get the area of triangle AGM, or the length of MN is the focus. So maybe we can think about use coordinate system to get the lines equation, right? Here, the lines equation, maybe you can suppose here E is the origin point, and this here is 2, 0, and we can calculate the intersection point coordinate and the slope and so on. Yeah, but here I just, it will make got a lot of calculation. So we can use the symmetry, right? Because we can easily to find this triangle ABH is congruent to triangle BCI. So this small triangle AGM is congruent BHN, right? Because we can easily to get this angle congruent to this angle, right? This SAS, and this one is BCS angle A side CIS. So these two triangles congruent. This angle congruent to this angle, and this angle is 120 degree, right? This also 120 degree because this vertical angle is an interior angle of regular hexagon, right? MNOPQR is 120 degree. Is the same thing here. So we will the last interior angle for these two small triangle, of course they were the same. So we got ASA. So these two small triangle AGM congruent to the small triangle BHN, right? So they will have the same area, right? And now we know G is the midpoint, and these two small triangles that have the same area, and we want to know the relationship between AM and GM. We know GM is congruent to NH. So if we know the relationship between them, we can use the cosine law. We can use the cosine law to calculate the length of GM, or we can get the length of AM. Then we can calculate the length of MN, right? So we know the area of them is the same. So this is the midpoint. I got an idea because we should use this midpoint. If we draw a segment GX is parallel to this side AH. So the height of this small triangle AGM will be this one, and the height of the triangle BHN on the side NH will like this one. So this is the midpoint, and they're parallel. So we know if this side is H and this side B, we can use Y. Right? BZ will be 2H. So they have the same area. It means AM will be double of the NH. So if we suppose AM is 2A, GM will be A. Oh, now everything is simple because we know the relationship between them, 2A and A. Now we can use the cosine law to find how long for A. Cosine law tells us AG squared equals 2A squared plus A squared minus 2 times 2A, this side times cosine 120 degree, so it's 4A 5A squared. This is negative 1/2 times this negative positive, so it's plus 2A squared. We can get 7A squared. Then we got AG is 1. We got 1 equals 7A squared. Now we got A squared is how much? Is 17. A equals square root of 7 over 7. Okay, we know 2A, and here is we know NH congruent to the GM. Here is A. Now we just need to get AH, then minus 3A. We will find the MN, right? And we can use MN over AB, then squared. We will find the ratio of the two regular hexagons area, right? Yes, we can use the cosine law again. I mean AH squared equals AB squared plus BH squared minus 2 times AB times BH, also times cosine 120 degree. So it means 2 squared is 4. Oh, no. AH squared is what I need, right? AH squared equals AB, that's 2 squared, that's 4 plus this is 1 minus 2 times 2 times 1. Oh, is almost the same thing like this one, right? So we know, and times negative 1/2, so it's 7. We got AH equals square root of 7. Then we will get mn equals square root of 7 minus 7 square root of 7. So how much for that? 6 square root of 7, right? That's mn. So the ratio we want to get is 6 over 7 square root of 7 over, oh yeah, here we are not just 7, so we need 3 times of that. Sorry, here is 3a, we need 3 times this one, so that's 4. That here is 7 over 7, right? 7 over 7, that's 1. So here is 4 sevenths times square root of 7, and r equals the square of this 4 sevenths square root of 7, and AB is 2, right? Then squared. So what's the result for this one? So we can get that here, and here is 2. So is 2 over 7 square root 7, then squared. So we know 2 squared over square root of 7, that's 7. That's 7 times 7. So 7 over 7. So it's 4 over 7. Then we got the final answer. M over n is 4 over 7. Then we find m plus n equals 4 plus 7. That's 11. The final answer. So this problem looks like complicated, but it's just to combine a lot of basic concept and basic knowledge skills. We just included how to get the area of a regular hexagon and how to get the area of a triangle, right? And the most hard part we just need to know here is an midpoint. Then what's the relationship between these two sides? Yes, sometimes the given information just implied us to get how much you can understand, how long you can go ahead. So here we just use this midpoint to get a relationship between AM and GM. That's the key point. So if we got this, all the problem is easy, right? So even though is the Aime12 problem number 9. I hope you enjoy it. Thank you. Bye.